There's one method on Vec which should be impossible really. I'm talking about the with capacity method, which is a way to reserve space, trivial at first perhaps, but fascinating when you consider that there are no trait bounds on that method at all. No copy, no clone, no default. It will work happily with every type that you give it. Let me show you what's going on. Our task is to initialize a vector. So we'll start by creating a new one that's empty, and then I will add some items to it. And let's go. So there's my 3 zeros. Then you'll say, hey, I know that there's actually a fast way to do that. And this fast way is with a macro. It's actually not going to solve the problem that I'm going to introduce very, very quickly. Let's get back to our original code. What we want is to kind of simplify this, and we could use some sort of looping construct. And you think, you know what? I know how to go even better than this. I can create some sort of function, and we'll call it filled because we want a vector which is filled up with items of some type T that we don't even know about. We copy our code across, and we immediately kind of get stuck because what are we actually inserting as the default value? Okay, so 0 is not going to work because 0 implies that it's a number that we're talking about, but we want to be very generic. So we know that there's a default trait, and to use the default trait looks something like this. We call the default method of our T, whatever that T happens to be. And we'll get our vector of 3 items. And there our zeros will appear again, except it's now asking, Rust is asking which T to actually provide. So we could do what we have been doing and just use it like an integer, or we could be very creative, let's say, and use a character, although I don't know if character has a default. Oh no, it does. Let's say that we wanted to do something slightly different. Instead of having a default provided by the type system, let's ask for some sort of prototype, which we then duplicate multiple times. So it's an instance of T, let's say. And we put our prototype there. And now instead of having a 0, we could put in, I don't know, we'll be boring and just put in asterisks, but we could have put in like some sort of emoji, for example. That would have been fun, but we'll carry on. Oh, use of moved value prototype. Move occurs because prototype has type T, which does not implement the copy trait. It's saying that you can't put the prototype into multiple boxes. It doesn't make any sense unless you're able to copy them. And we could, if we wanted to put in, you know, some sort of string, because a string slice will implement copy. But I finally want to get to with capacity. With capacity is really interesting because it doesn't have a trait bound in the same way. If we go and look at the actual method, its signature just takes a single parameter capacity and it returns vec of T. There is no further constraint. It doesn't require default. It doesn't require copy. It just works. The reason why it works is fascinating. With capacity, and we need to provide our 3 here, is not actually putting a value into the memory that is allocated. It is reserving so-called uninitialized memory. Uninitialized memory is highly dangerous. It's one of the most hazardous areas of unsafe code because of all of the very delicate rules that relate to it. The reason why I think that vector is magic is that it provides access to undefined memory in a way that is completely safe. You get access to these hidden superpowers without the hidden risks. You cannot create undefined behavior from within safe Rust.